Okay, so now we've transformed our graph and our uncertainties. Now we need to describe the graph and produce the equation. So, what have we got here? Well, as the square root of mass increases, the period increases, the data forms in a straight line about our line of best fit, and it's got a positive gradient and a positive y-intercept. Okay, so the square root of mass increases, the period increases with a positive gradient and a positive y-intercept. And it's constant as well. Constant gradient with y-intercept. Fancy word for this is there is a positive linear relationship between period and the square root of mass. More spelling errors. Okay, scrolling down. So let's now rewrite the equation. Okay, so here we go. Now, this is some of last year's work, so let's do this part quickly and then add on the level 3 stuff. So let's put an equation in. So on the y-axis is the period, okay, so t equals. Now the gradient is 0.744, 0.744 times the x-axis, which is the square root of m, plus 0.047. Now, that's last year's work. Okay, so let's quickly now extend it into this year's work, and Plotly makes this really easy. So our gradient, sorry, let's use an equation for this because you'll see why in a minute. Your gradient equals, now, 0.744. Agreed. But there's an uncertainty in it. Yeah, the straight line could be shifted up and down a bit because it's constrained by these points. It doesn't have to go through the center. But the really awesome thing is if you actually have a look in here, it tells you what it is. This value right here, these values right here, the gradient is 0.744 plus or minus 0.028. 0.028. In other words, the gradient has variation in it by that much. Now let's do the same thing for the y-intercept. Y-intercept equals, well, we knew it was 0.47, 0.047, and it's got an uncertainty as well. Where is my greater uncertainty? And it tells us there it's 0.013. 0.013. Unfortunately for the Americans, they use B for their y-intercepts as opposed to C, which we do here in New Zealand. So, there's our two gradients. Now we could do some more work here. Okay? So, that's what's required, but we can do better than this. Because, as we said before, uncertainties really only have one significant figure when you're doing them. Okay, so let's copy all of this and then we'll do some rounding. Okay, this has to obviously round up to 0.03. Now, even if it was 0.021, say, we'd still round it up because we always round up our errors. And this is at the second decimal place. Yeah, so we have to have this rounded to the same decimal place. So we just drop that figure off there. It rounds to 0.74. This one, let's copy the y-intercept. And this one here rounds to 0.02, not 0.013, because you always round your uncertainties up. And this here would round to 0.05. This rounds normally, because they've got to be at the same level of accuracy, the same decimal place. Okay. Now we can do even better now with our equation. So here comes our final equation. Let's copy this whole equation down to make it easy for us. Okay. So our gradient is this. So let's take that. Let's put a bracket in and paste that in there. There's our gradient. And let's do the same thing for the y-intercept. Let's paste in that. Okay, so our final equation is the t, the period, equals 0.74 plus or minus 0.03, that's the uncertainty in the gradient, times the square root of mass, plus 0.05 plus or minus 0.02. Now, we can do some more work with our gradients as well, if we like. Let's skip this down here. So let's write an equation. So our gradient, the center of the value for the gradient ranges between these values. Okay, so it's going to be less than equal something and up to a greater than or equal, because it fits between two bounds. Now 0.74 is the middle, but it could be smaller than that. It could go all the way down to 0.71 and all the way up to 0.77, because it's plus or minus 0.3. So 0.74 minus 0.03 is 0.71, and 0.74 plus 0.03 is all up to there. So that's what our gradient could range between. What about our y-intercept? So let's copy that there to make it easy and change that to y-intercept. So the smallest it could be would be 0.05, take away 0.02, which is 0.03. And the biggest it could be would be 0.07. Okay, so now we've got our data described in several ways. We've got a gradient with an uncertainty included. We've got a range our gradients could fall between, and we've got our y-intercept given with an uncertainty, and we've got a range our y-intercept could fall in between.